Okay, so next up we want to use Gaussian elimination to solve this system of linear equations right here. And to do it, we need to first set it up as a matrix, okay? And then we want to put that matrix in reduced echelon form, a reduced row reduced form. And we do it using three operations we're calling row operations, and we'll talk about that as we go along. So let's take care of the first thing, which I think is really the easiest one, and it's turning this into a matrix, this system into a matrix. And it's just the backwards of what we were talking about earlier, where remember where each column is like kind of, it coincides with the variable. So for example, the variables x has 2, 1, and -1 as coefficients. So that's what we would write down the column, 2, 1, -1. And you do the same thing for y and for z. So y has -4, -2, and 4. Z has 1, 2, and -2. And then, because it's an augmented matrix, your equal sign, and then your -7, -2, and 3. So this is the matrix that we're going to do, that we're going to row reduce. And row reducing using, Gaussian elimination comes down to, we're going to use three operations to change this, to transform this matrix into one where there's ones down the diagonal and then zeros underneath. Okay? And so that's our goal, is going to be get our matrix into that form. And there's three operations that can do that for us. Let me just review what those operations are. The first one, which is the easiest, is the row swap. So swapping rows in the row operation is one thing we can do to transform this matrix, swapping rows. This is kind of like the first obvious one. Remember we want to put a 1, get the 1 up here. So how do we get a 1 up there? Well, if we swap these two rows, let me change my marker here. If we swap row 1 and 2, you can see that that would put the 1 up here, and then we'd have the 1 where we want it. So a row swap is what we want to do as our first move. And let's just go ahead and do that. I'm going to change my marker again. We're going to swap rows, and we're going to get a new matrix. It's going to look like 1, -2, 2, -2, 2, -4, 1, -7. So I just row 1 and 2 swapped. Okay, -1, 4, -2, 3. So now we're working with this second iteration. Okay. What are the other row operations we can do? Well, we can also do a constant multiple of an entire row. So you can take a row and multiply it by a constant number, and then the third operation that we can do, and this is the one, it seems a little crazy, but it's actually the most useful one. I call it row replacement. So you replace row, whatever row you're talking about, we'll call it row R, with row R plus a constant times another row, row S, pretend. So this here is going to be your new row R, okay? And you're just replacing row R with row R plus a constant times row S. And we're going to be doing that a couple of times, so you'll see what I mean by row replacement. Okay. So now we got this 1 up here, and once you do that, Gaussian elimination means now you get to eliminate underneath. I'm going to use a different marker now. these into zeros. And that's the Gaussian elimination part. How do we do that? You do it by row replacement. We're going to replace, and I'm going to change my marker here. We're going to place row 2 with row 2 plus -2 times row 1. Why -2? Because what you do is, so y -2, it's the negative of this the original coefficient, right? The original thing you want to turn into 0. And then by design, this will become your new row 2. Okay? We're going to also do that with the third row. The third row is going to be row 3 plus, and then looking at this coefficient here, that's a -1, so we want it to be negative of -1, which is +1 times row 1. It's just row 3 plus row 1. But when you do that, you take row 3 and you add row 1, this new row becomes row 3. So let's actually do these operations here. I'm going to scooch down so we can give ourselves some room and work each one of these out. So as you know here, notice here, we didn't do anything to row 1. So our new matrix in this process would just be, okay, original first row, right? And then now our new row 2. What's our new row 2 look like? Well, it's row 2, which is 2, -4, 1, -7, plus, so that's row 2, plus -2 times row 1. You have to multiply -2 everywhere, throughout the entire row 1. So throughout row 1, multiply -2, okay? And then we're going to get -2, +4, -4, and +4, right? And then once you do that, we're going to add these two up. And you would do it, you know, by doing it component-wise. Add up this way. And we end up getting 0, 0, -3, and -3. And this becomes our new row 2. So I'm going to write it there. 0, 0, -3, -3. All right? Repeat this process now for row 3. Okay, I'm going to erase this here so we have room. Okay. What is the new row 3 is row 3, which is -1, 4, -2, 3, plus row 1. Row 1 is 1, -2, 2, -2. And then we just add it again, straight down, component-wise. Okay, and we get 0, 2, 0, 1. And so this becomes our new row 3. It's 0, 2, 0, 1. Okay, and we keep moving along using these row operations to get our matrix in reduced echelon form. Okay, so now we're at this matrix. What can we do? Let me change my marker here. And I hope you said we can swap, right? Because remember, our goal is to get ones down here. We want ones down here. So if I swap these two rows right here, I meant to use the red marker there. If we swap row 1 and row 2, row 2 and row 3, then we get a matrix that looks like, okay, 1, -2, 2, -2, and then now it's 0, 2, 0, 1, 0, 0, -3, -3. So this is looking more like the diagonal type matrix, and We're getting closer to what we want. What's the final move? Well, we want this to be a 1 as well as this. Okay, so what do I have to do? Multiply by, let me multiply this whole row by 1 over 2, the reciprocal. What about this row? If I multiply it by negative 1 over 3, then I'll turn these into 1s. And that's one of those operations that we can do, is multiply a row by a constant. So we're ready to do that simultaneously. Let me change my marker. Okay, and we end up getting, okay, we didn't do anything again to the first row, so we just bring it down. It's 1, negative 2, 2, negative 2. And now what's our second row? It's going to be 0, 1, 0, 1 half. What's going to be our third row? 0, 0, 1, 1. Okay? And now it's exactly the form that we want. 1s down the diagonal, and now these are all 0s. And that's what we wanted. So how do we use this to get our solutions? Well, we convert back into the system of equations. And starting from the bottom, okay, what does, and now I'm going to change my marker here. We're ready to do the solutions. So what does this last row give you? Remember that the columns are the variables, right? So this last row is telling you z times 1 equals 1. What about this second row? That tells you, because you got zeros here, right? It tells you that 1 times y, so y equals what? A half. So you know what the x value is, the y value is, you know what the z value is. And then this third run, well, since you know what y and z are, you can actually plug those values in. But let's write the equation down. It's going to be, let me scooch it over a little bit. Okay, it's going to be x minus 2y plus 2z equals negative 2. All right, and what we got to do now is do a replacement. We know what y is, and we know what z is, right? We do a replacement there, and solve for x. So in the end, we know that x is going to be, so x and then minus 1 plus 2 equals negative 2. So x ends up equaling negative 3. So this is our solution. Let me kind of get rid of these other. Okay, that's how we get our solution. That's how you use Gaussian elimination.